Welcome to our demo of Decidr. For this demo, please consider the following example. It's a hot day and Aisha wants something cool to have, but she and her friends can't decide on what to eat or drink because they keep talking over each other. Fed up, Aisha finally decides to use Decidr to settle this once and for all. She goes ahead and opens the app and decides to create a new room. She goes ahead, creates a new to create a new room. She first selects her, her avatar. She then selects an anonymous name and selects Go. She then enters her question, selects the room duration to be 6 minutes. She selects votes per person to be 3, and she creates the room. The room has now been created. With the room created, Aisha goes ahead and shares the room code with her friends. And following a similar process to her, they too join the room. As you can see, Aisha received an update that her friend has joined the room. And as you can see, both Aisha and her friend received an update that the second friend has joined the room. Now that everyone's here, Aisha decides to go ahead and add some voting options. Aisha then decides to vote for slushies once and for ice cream once and decides to hold on her vote. Her first friend votes for slushies. Her second friend looks at both options, looks at the chart, and sees that slushies are definitely more than ice cream. So she goes back, she thinks about it for a minute, and she adds a new option. She then decides that all of her votes go towards cold drinks. She looks at the chart, she sees that cold drinks are more than slushies, and she's happy. The first friend thinks about the new options and she decides to vote for ice cream once and cold drinks once so that everybody's happy. And Aisha, reviewing her options again, decides that she really wants ice cream, so she votes for it again. Now that all the votes have been cast, everyone reviews their yes, everyone reviews their vote, and Aisha ends the session early. And there you can see the result with cold drinks with 4 votes. And at the end of the day, Decider has helped this friend group come to a very quick conclusion to a very simple question. Thank you.
So first off, let's go over the front end of the code. So let's start with the user context. In the user context, we can see that there's update user details, which you're pretty much updating the information of the user. And then you can also see that the context is going to be used for the other pages as well. The main page, we are updating the user details, which is pretty much the schema of the thing, what we're going to be storing on the backend side. We're pretty much just like passing the information as we navigate through other pages as well. So for example, we went from the main page to the nickname page. We can see that this information is passed over, just so we're not using like it's a lot more like efficient than state management. So now let's explore the backend side. So let's start with the So front end we're gonna be doing like React.js, and back end is gonna be MongoDB with Express. So if we look at the server.js, at the very top we have Mongoose, which is how we're like connecting it to like MongoDB as our database, and our backend is like on localhost 3001. Our front end's on localhost, and as you can see on the routes too, there's gonna be a lot of files, right? So these are gonna be our endpoints that we're gonna fetch from the API to like use into our database. So let's give an example. So in here we have like a GET request for the room, which pretty much gets the user schema of whatever it is that we're like storing. So you might like get like some information about that user that you want to like store in the database. In here we have rooms, but if we change it to like this users, it stores the API for the users, and you can see like all the information stored here. So that's pretty much how our schema works. And I'll give Lukeman the opportunity to present the other parts of our presentation. But before I pass it over to Lukeman, please take a look at the schema. So in the user schema, we have room ID, socket ID, username, profile picture. We use sockets to like connect the users together. So Lukeman will go over the broadcasting, and room schema will have like all of these features, which is room ID, questions, vote options, end time admin user ID, and all of the other features. So and as you can see, we also have like a nested array, which stores the option text and votes, just to like record the votes for each user.
Next, I'll dive into the real-time broadcasting in our code. Let's explore how it all works. First of all, we're utilizing socket.io for this purpose, a powerful technology that enables real-time communication between users. I'll go over some of the broadcasting triggers. Our system is equipped with various triggers that indicate broadcasts. Here's a couple of examples. Adding a vote will broadcast an event across all the users in the room. For instance, clicking on this add vote button just broadcasted an event. Next, I can add another option, say, and as soon as I click this event would be broadcasted across all the users. An even more exciting kind of event is when a user joins. So I'll just copy this room ID, verify it, make a profile real quick, choose an avatar, and as soon as I click go, this event will be broadcasted across all the users in the room. And there you go. Next, I'm gonna go over how this works. What happens when a front-end user triggers an event. It's a seamless process that ensures everyone is on the same page no matter when they join. First up, the moment an event is triggered, our MongoDB database swings into action. It gets updated instantly. This is crucial because it helps us to maintain a persistent state. So if a new user joins a room, they're not left behind. They receive all the latest details right away. The update to the database happens incredibly fast. We're talking milliseconds here. This speed is key to ensuring that our front-end users don't experience any lag or delay. Once the database is updated, the next step is broadcasting the event. This is done through socket.io, running on our Express.js backend server, which handles all the event transfers. Once socket.io completes its job, every user in the room, except for the one who initiated the event, receives this broadcast. It's all about keeping everyone synchronized. The handling of events in the front end is done through a custom React hook we developed named useBroadcast. This hook is central to both sending and receiving events. Our approach with the centralized custom hook ensures we have a complete control and efficiency in handling these real-time interactions.